of the sizes of individual branches within a single tree.
If they're correct, studying a single tree will make it easier to predict how much carbon dioxide an entire forest can absorb. When they finish here, they take their measurements back to base camp, where they'll see if their ideas hold up.
So is this is the tree plot, right?
Yeah. The cool thing is that if you look at the tree, you see the same pattern amongst the branches as we see amongst the trunks of the forest.
Very nice.
Just as they'd predicted, the relative number of big and small trees closely matches the relative number of big and small branches.
It's actually phenomenal that it is parallel. Yeah. The slope of that line for the tree appears to be the same for the forest as well.
So I guess it was worth cutting up the tree.
It was definitely worth cutting up the tree.
So far, the measurements from the field appear to support the scientists' theory that a single tree can help scientists assess how much this rainforest is helping to slow down global warming.
By analyzing the fractal patterns within the forest, that then enables us to do something that we haven't really been able to do before. Have then a mathematical basis to predict how the forest as a whole takes in carbon dioxide. And ultimately, that's important for understanding what may happen with global climate change.
For generations, scientists believed that the wildness of nature could not be defined by mathematics. But fractal geometry is leading to a whole new understanding, revealing an underlying order governed by simple mathematical rules.
What I thought of in my hikes through forest, that, you know, just a bunch of trees of different sizes, big ones here, small ones there, looking like it's sort of some arbitrary, chaotic mess, actually has an extraordinary structure.
A structure that can be mapped out and measured using fractal geometry.
What's absolutely amazing is that you can translate what you see in the natural world in the language of mathematics. And I can't think of anything more beautiful than that.
Math is our one and only strategy for understanding the complexity of nature. Now, fractal geometry has given us a much larger vocabulary. And with the larger vocabulary, we can read more of the book of nature.
On NOVA's Hidden Dimension website, explore the Mandelbrot set, see a gallery of fractal images, and much more. Find it on pbs.org.
Next time on NOVA, in an aerial arms race.
The MiG-15s were fast, very heavily armed.
Over 30 pilots mysteriously disappear.
They may have survived the shoot-down of their plane.
Scientific detectives uncover their stories.
Lo and behold, they wore Captain Cope's dog tags.
And the technological secrets behind the world's first jet war. Missing in MiG Alley on NOVA.
Major funding for NOVA is provided by the following.
One of the biggest challenges for geoscientists is trying to find the oil and gas that's hidden below the surface of the Earth. Lately, our researchers have developed a new technology called R3M. You can't see it and you can't feel it, but the Earth has electromagnetic waves. And if you build the right kinds of listening devices, you can make sense of those waves. So using those tools, we can supply more of the energy that we need with less of an impact on the environment.
And David H. Koch. And
Discovering New Knowledge. HHMI.
Major funding for Hunting the Hidden Dimension is provided by the Alfred P. Sloan Foundation to portray the lives of men and women engaged in scientific and technological pursuit. Major funding for NOVA is also provided by the Corporation for Public Broadcasting and by PBS viewers like you. Thank you. To order this NOVA program for $24.95 plus shipping and handling, call WGBH Boston Video at 1-800-255-9424. NOVA is a production of WGBH Boston.